Hey now, it's time for that bell ringer again, every day, same time, every day. Do the bell ringer first. That reviews some of the stuff that we talked about the day before, preps us for the day to come. Then we have an ed puzzle lesson, and then usually the third item of the day is some information for you to collect, or for me to give, or an activity for you to do, or something like that. So let's do today's work, shall we? Yeah.
All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
He's interesting too.
It's Mr. Kovacs class. And he's super cool. It's Mr. Kovacs class.
Babies. Okay, an embryo is not a baby. An embryo is like before you're a baby. And then actually before you're even a fetus, you're an embryo. It's like an embryo is when you're putting all the pieces in the right place. And then a fetus is when you got all the pieces in the right place. You just have to grow big enough so that you'll survive on your birthday as a baby, right? And of course, the nuts and bolts of all this is mom makes egg, right? There's an egg maker, 23 chromosomes in the ovum, in the egg. Pops makes sperm cells. He makes a whole bunch of them. Each one has 23 chromosomes in it. One sperm cell fertilizes the one egg. You now have a full set of 46 chromosomes. And they're paired because mom and dad give the same ones. We call that a zygote. A zygote. And then yesterday I talked about amniocentesis, which is a way to get a picture of chromosomes, and that requires finding some of the baby's cells. And the way they do that is by looking for the amniotic fluid, right? So this is baby in the womb, right? The womb, of course, is called the uterus. That's its term, not the stomach. There's only one way to get a baby into a stomach, and that's to eat it, which is not legal, right? Uterus, of course, has got the baby, and the baby is attached to its own placenta. The placenta sticks up next to the uterus, and that's where mom and baby exchange. They exchange things like carbon dioxide and oxygen and uric waste and nutrients. And then, of course, on birthday, mom's got to push baby through the birth canal. And happy birthday, yay. All right, but in amniocentesis, you take a big, long needle, and they look for this fluid that the baby's floating around in, the amniotic fluid, and they take a sample of it with the idea that that fluid is going to have some of the baby's cells floating around in it. And since the baby is so rapidly growing, or I guess the fetus, not a baby yet, fetus is so rapidly growing, a lot of cells will be in mitosis. They'll be copying themselves. Then you take those baby cells and you incubate them, you give them some nourishment, let them grow and divide and grow and divide and grow and divide. And then you put them on a slide and stain them. And then you got to look at that under a microscope, and you're looking for cells that are usually in metaphase. And if they're in metaphase, they have discernible chromosomes. And you find one where you can see most of the chromosomes, and then you take a picture of it. And then the fun part begins, the part that you're doing in lab. But then once you have the picture, you've got to cut out each chromosome and pair them up. And you're looking to see that you have 23 pairs, that you have the right number of pairs. It'll also tell you whether or not the baby's going to be an egg maker or sperm maker, depending on the sex chromosomes they have, right? Like, they'll have 22 autosomal chromosomes. The last pair will be the one that determines whether or not they make eggs or sperm. The result will be this nice karyotype with all the chromosomes lined up and numbered. And then, like, you can tell, since there's two X's, this person who has yet to be born, but this person is most likely going to make eggs when they are born. So they'll be egg makers. And then, unfortunately, or maybe fortunately that you know this ahead of time, this person's going to have 3 copies of chromosome 21. This person's going to have trisomy 21. They will have what we call Down syndrome, which means they are going to experience a delay in development as they progress through their lives. That'll make some parts of being a human being more difficult than, let's say, a normal, regular, non-trisomy. Doesn't mean they will have a difficult life. It doesn't mean that that they can't have a productive and valuable life, but it is a predictor that they're going to have some developmental difficulties. What's maybe an advantage of doing this is that the parents will know ahead of time and will be able to prepare their lives to accommodate the special needs of this offspring. Does that make sense? All right, karyotype, that's what we've been studying. We're going to talk more about how you split the chromosomes up in meiosis. Meiosis.